So, we can actually use proportional relationships in our everyday lives to solve real-world questions. Let's check out this one for fun, and you'll see that, in fact, it's an exemplar for lots of possibilities. So a student wanted to find the height of a giant inflatable ape. You ever see these things sometimes at car dealerships and things? That's really big apes. So here's what she did. She measured the ape's shadow and her own shadow and then made a diagram. And the student's height turns out to be 5 feet 2 inches. And the question is, what's the ape's height? Okay, so check it out. Here's my version of this. So we have the scary inflatable ape here, and here's the student who's interested in how high that is. Now, there's the sun that's sort of shining way over here somewhere, and it's casting down and making a shadow. But you see, the important thing is that since this is a level ground, we're going to assume, and we have the sun coming down, then in fact, these lines, in fact, are going to be parallel. In particular, what we see is the angle that the top of the ape's head, sort of coming down, that line of sight with the ground and the level ground itself, that angle E is therefore going to be congruent to the angle B, the angle formed from the top of the student's head down to the ground, to the end where the shadow is, over. So we have these two angles being the same. Now, it's easy to measure what the length the shadow is because the student has to measure along the ground. It's climbing up inflatable ape that you want to try to avoid. So here she measured 10 feet 6 inches, and her own shadow she could measure or have a friend measure to be 3 feet. Her height we know is given to be 5 feet 2 inches, and so the question is, can we use all this information to find this mysterious height? The answer is yes, because we have similar triangles. Now, do you see it? Why are they similar? Well, we've already established that these two angles are congruent, and of course, since I said we are at level ground, then we know that this height actually produces a 90-degree angle. This is the right angle, and all right angles are congruent, so I have this angle congruent to that angle, this angle congruent to that angle, so by the angle-angle similarity theorem, we know these two triangles, in fact, are similar. Well, great. If we know they're similar, then we know that ratios of corresponding parts are going to be equal, so we can set up a proportion. So let's actually do that. So what I could say is, well, this is to that as this mysterious ape height is to the known height of the student, and then solve for that. So let's set up the proportion. So the proportion would be, well, this is to that, so shadow is to shadow. Now I should convert things to the same unit, so let's just convert everything to inches. 10 feet, that's 120 inches, plus 6 inches is 126 inches. So I have 126 inches is to, now I don't want to write 3 feet, let's convert everything to inches, so I need to write that as inches, which is of course 36 inches. And that's going to be equal to, so what's the proportion going to be? Well, the ape height to the height of the student. So the ape height, all right, ape, is to, and then what's the student's height? Well, 5 feet 2 inches. Let's convert that to just inches, and we see 62 inches. And now I can solve this for the ape height using the cross product. So I see 36 ape equals, well, 126 times 62, which is 7,812. If I divide both sides by 36, I see that the ape height is equal to 217. So 217 feet? No, remember our units, we converted everything to inches, so these are actually inches. So what happens? Well, if we now divide through by 12, I can see the answer of 18 feet. 18 feet. So the answer to this question, we can now see, is actually 18 feet and 1 inch, because the 7, of course, we know. So 1 little inch right there. In fact, I'm going to put the 1 inch right here. There, 1 inch. 18 feet and 1 inch is exactly what 217 inches mean. So the bottom line is, notice how we were able to use this property of similar triangles to actually find a height that was quite dramatic. About 18 feet in height is pretty serious. So this really allows us to do things in practice, finding, for example, the heights of various objects that are just too tall to measure, but using similar triangles with sunlight and shadows, we can actually figure it out. Pretty cool stuff.